For this video, we're doing just the calculator portion of the chapter 1 review. So quick overview here. You need to be able to create a table in Desmos, get a linear regression model, interpret some things about that. Given a function, you need to be able to create a composition and plug numbers into functions, set functions equal to values, and solve. Okay. I have kind of a slight mix up in the way that I put this table. So let's go ahead and read through it, and then we'll look at these first two problems before we talk about how we're going to enter this in. And I won't have this mixed up on our quiz. A pediatrician wanted to find a model that related a child's height, h, to their head circumference, c. She randomly selects 9 children from her practice, measures their height and head circumference, and obtains the data shown in the table below. Now, normally we say, okay, top row is X, bottom row is Y. But the input here is the head circumference and the output is the height. I mean, I guess you could do it either way, but part A just says use a graphing calculator or Desmos to find the linear model, okay? And then down here it says what's H of C. So I'm basing my input output on this right here. So this function notation means H is the output and C is the input. So if H is the output, the H row is the Y, and if X is the input, or I'm sorry, if C is the input, then the second row is the X. So that's confusing. I already printed these reviews. That's why I'm not just fixing it, whatever. So when you start a table, make sure that you're putting head circumferences in for X. When you finish typing, do a quick check for typos. These numbers are very similar, so it's easy for your eyes to jump or skip one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just looking through them again. 0.4, 0.9, 0.9, 0.6, 0.3, 0.5, 0.3, 0.5. Okay, that looks fine. And then type in the heights, excuse me, up here. I'm going to double check those as well. All right, those seem okay to me. Excuse me. Remember, you can zoom fit to see the data. This does not look perfectly linear. We will run a linear regression anyway to get a line of best fit. In case I'm doing anything with the equation, I'm going to copy it on the next line so it's ready to go. All right, so let's write down some answers. This says, using the graphing calculator to find a model of the data, use the correct variables. So I'm not going to use Y and X like Desmos shows me. I'm going to use H and C. So H of C equals, remember not to round anything here, 2.14974. Instead of X, we're using C minus 10.52715. So we do not round these values. When we plug numbers into this, we round those values. What is H of C model and what is it a function of? So remember, you're just modeling output as a function of the input. So what is the output? Height as an input of circumference. Maybe I should say head circumference. Okay, that's it. Interpret the slope found in part A. Remember when we had a quiz over this, there's a script that we put in the notes. You should start off with on average because this is definitely not the slope between every 2 points. So on average, the height increases by how much? The slope. This you can round, 150. And what is height measured in per circumference? Inches per inch. So inches. Now instead of like inches per inch, I might say like per 1 inch increase in head circumference. It's not wrong to say inches per inch, but they're like different measurements. So inches in height per inches in circumference or something. But I'm just writing it out like this. So on average, the height increases by 2.15 inches per 1 inch increase in head circumference. So as the head gets bigger, height gets taller. Use the model from part A to predict head circumference of a child who is 3 feet tall. Now remember, that's feet, and the circumference, we're trying to predict the head circumference. So we're setting the height equal to 36 inches. So h equals 36. We want to find c. So 36 equals h of c. I can use Desmos for this. So I can type in the line y equals 36 and see, now that's off my screen a bit, but see how you can see the numbers here? You can zoom out, or you can this. You're looking for the intersection point. So that head circumference would be about 21.643. 21.643. Now, is that feasible? 21.643. I don't have a tape measure to see what my current adult head circumference is, but I have a feeling it's not a linear relationship. It makes sense that your head circumference does not continue to grow as quickly as your height. So I have a feeling it tapers off. This is probably like some crazy like basketball head or something. But anyway, this is what the model says. We're not worried about whether or not it's actually realistic. It doesn't ask us about that. If we did have a question of like, well, is this model even reliable for predicting for 3 feet tall? Well, no, because that circumference is outside. I mean, we don't know if it's reliable. That circumference is well outside the domain of circumferences we started with. All right, what about number 2? Kinetic energy is directly proportional to the mass of an object and to the square of its velocity, which is this relationship here. K is measured in joules, M is the mass of an object in kilograms, and V is measured in meters per second. So that's 3 different variables right there. I'm giving you a specific scenario. So suppose an object has a mass of 3, so that's been put in for you. It's been moving for 10 seconds. The object's kinetic energy would be modeled as K of V equals 3 over 2 V squared. So V is the actual input and K is the output. Suppose the object's velocity is modeled as a function of time. So V of t is equal to 4t minus 1, and it has this little domain. Write the model K of V of t with domain and interpret the meaning of the model in its context. So this means go ahead and compose K of 4t minus 1, because that's what V of t is equal to. So instead of 3 over 2 V squared, we're going to put in 4t minus 1 squared. What would the domain of this be? It always carries over the inner function's domain, so we can only use t values from 0 to 10. Interpret the meaning in context. Use the same script as we did up here. Okay, so K of t, I know it says 4t minus 1 here. That's just to get you to evaluate here. So in general, K of t models what is K? Kinetic energy. Based on what is t? Time. And I don't have to say any more than that. It's time like past, I guess, or time that this object has been moving. But you can just say based on time. Find the object's kinetic energy at t equals 4. So evaluate K of 4. You're plugging that into here. So you don't have to show me the work for that. It would be plugging in 4 for the t right there. But you can go over to Desmos here. Let's cross out our old stuff. All right, so K of t equals 3 over 2, 4t minus 1 squared. Remember, we're just trying to find K of 4, so we don't need the graph right now. It's coming out to 337.5. So I can write that down. So that's 337.5. Kinetic energy was measured in joules, so you want to make sure that you label everything. And then this says find a time at which the kinetic energy of the object is 1,000 joules. So what I want to do is set K of T equal to 1,000, and I'd like to solve for T. I don't have to do that algebraically. It's actually better for you to, or like more efficient, I should say, to solve by graphing. You're less likely to make algebraic mistakes. So how do I solve that? Well, I want y equals 1,000, but my window is nowhere close to this. I could zoom out until I find things, but remember, you could also say, let's do zoom fit by making a little table. What was the domain here? It was 0 to 10. Now, my answer might be outside of 10, but I'm just going to see. So 0 to 10, k of 0, k of 10. Once you fill out the two endpoints of this domain here, then you can zoom fit. And actually 1,000 does fit within here. So here's the 0 to 10. I'm just going to click near here to see the little gray intersection point. And rounding to 3 places for the AP exam, 6.705 is my answer for the input. What was T measured in? It was measured in seconds. So that's seconds. All right, those are the calculator skills that you need for this test. So you need to be able to input a table, do a linear regression, set an equation equal to a number and find the point of intersection, plug a number in, and get an answer from that. All right.